Okay, good afternoon all. We're on the final stretch now for the IoT part of the course. To give you just an overview of what's still to do. Today I'm going to have a look at, well, I moved the Alexa bit back a week, so I'm going to have a look at the critical issues facing the Internet of Things this week. The lab this week and next week, no sorry, this week because it's due in on Friday. This week I'm going to devote the lab to assignment help again. Probably fluctuating about helping people with that. Next week the lab will, for the people who missed out on doing, because we were doing the assignment, the lab's on using Amazon Alexa, perhaps using this Node-RED interface as well. Yes, not needed for the assignment, just a good skill to sort of have. Also next week, got this guest lecture from Jed Till from Till Systems, giving a talk on how his company implements IoT. As I say, he's a good employer of MMU graduates, and they really do make a good use of IoT in their smart home division and their smart complex division where they're looking at controlling buildings in general for it. He'll sort of go over where he uses IoT and where his sort of company came from in using that, but also how much they use Node-RED and how much they're starting using the Amazon Echo as part of their interface to it. So it ties in very well with what we're doing. Now, I appreciate this is after the assignment's due in. Can we have a good turnout for this, please? We are bringing him in. And yes, it's not part of your assignment, but I still want you all here, basically, to have a see what he's got to say on it. So that's the next couple of weeks. From January, you won't be having any of me. So, we're work time too. From January, you're having Mohammed Kaleem, who's going to be taking iOS development, so iPhone development in the Mac Labs. You can still perhaps sort of interlink with what he's doing in sort of controlling fidget things, but he's not a fidget sort of Internet of Things sort of type person. He's concentrating really on iPhone development for that. But if you tie the two together in a project, it still might be useful to figure out how to do that. There's no demo this week. Ooh, we always like our demos. That's because next week is effectively all demos. He's bringing in some of his kit with his sort of guest lecture, and it's going to be no talking of me. It's going to be more or less sort of all demos of how somebody's using it there. This issue today about the critical issues facing the Internet of Things. Just before I get into that, I probably won't be able to do sort of the whole set of it. There was one section that I didn't really go too much on in when we were doing the networks and operating systems. These slides that I'm about to just have a quick look at here, they're from the, I'm trying to remember which chapter, I think it's chapter 4, but it's the one on networks and operating systems. And you know, quite often I don't get up to the end of the lecture slides, but there's a bit in here that might help you with your assignment, where people are thinking about comparing different network protocols and what's this thing meant by Zigbee, what's meant by Bluetooth, and where you might use one over the other. So there was a section just towards the end of this on sort of different communication protocols, wired, wireless, where you might have sync nodes and sort of node or bridges, these sort of hub things in there, efficient routing, that sort of stuff. But just flicking through it, it goes over the standard sort of things like Wi-Fi rates, how fast they go. But the thing that might be of interest is this sort of background on what Zigbee actually is to it, how fast it can transmit, as opposed to other ones. So it's quite useful to know which types of network protocol are better than others. Much like you probably know about if you're going from A to B, you can walk, you can go by bike, you can go by car, you can go by train, you can go by plane. Some are a lot faster than others to do it. Some are a lot easier to manage, some can take a lot more in terms of cargo, and that's the thing that you have to decide with the different network protocols. Now Zigbee didn't sort of cover sort of too much into it, but just as a brief sort of outline to it, some of the benefits of it, it works pretty much in the same way or the same range that Bluetooth does, as in that it can have up to about 30 meters or so as its maximum distance. But the good thing about Zigbee over Bluetooth is they're going from sleep to active mode, how fast they can do that. A Bluetooth node takes a good few seconds to wake up. You may have seen that when it's pairing, perhaps in your car with, say, with your mobile device, or pairing with anything. It takes it 2 or 3 seconds to get that pairing in, and then says, okay, I'm paired now. Zigbee nodes can wake up in about 30 milliseconds, which is like, instantaneous. So if you've got these nodes dotted around your house, and you say to a node, can you just send me some information? If one thing's not going to wake up for 2 or 3 seconds, and the other one wakes up instantly, then that's that second one is a better one to go for, because it can be a lot more responsive, and by going to sleep means that it's not using power then. So it's like if some people can go to sleep, I'm certainly one. I take a good hour to wake up in the morning. I can get up, but I need to stumble around the house in a bit of a daze until your mind comes to. You've had a couple of cups of coffee, and then you're into it. Whereas some people, as soon as they're awake, boom, they're into action. They can start talking with it. They're the Zigbee people. I'm more your Bluetooth table, where a person where wake-up time can be a bit longer to get it. And that can make a difference, as I say, when you're interacting between these sort of different devices. Particularly if you've got, and again this is the case where you've got some devices that might be in some sort of network. One of the use cases that you've got is where you've got a hub. You might have a hub for, say, the Philips Hue, which communicates with a series of lights. So you've got one light bulb to it, which can be up to 30 meters away. But one of the things that I've often said to people in their feedback about what do you think of this diagram so far, the reason I ask you to do at least 3 lights is to have an indication of how these lights might be interconnected and how they form a mesh network. Because these things can intercommunicate. So if from my hub, I can send a message up to 30 meters, but an individual one can relay that message on for another 30 meters. So an individual light can be a lot further away, because that can then pass it on another 30 meters. So there's no particular limit to how far these things can go with it. It just means that the individual lights have to stay on more often. Not the light itself, sorry, the actual processor in it. They have to listen for incoming connections. And the people I've mentioned this to already are some people who've been seeing me individually. I say it's rather like in a lecture here. You can all just lay back and let me drone on, let it wash over you, or something like that. And then, but if you've got a friend who's saying, look, I can't make Nick's lecture, it's always really interesting, and I want to hear it live. So what you could do is get on your phone simultaneously, and as I'm saying something, relay that message out to them. But it means you've got to really concentrate on what I'm saying, transmit it on, get the OK off and get follow that, what's he said next? And then you pass it